Hi, my name is Kiran Sapkota with student ID 10287395. Today I am going to do lab 9 of interface. Uh, as we did in previous labs, we need here 0.2 second delay and 0.5 second delay. So we have calculated a value to create timer delay for 0.2 and 0.5 second over here, and also we need to have a 60% and 100% duty cycle. So with the information provided on our lab, we have calculated required value for 60% duty cycle and 100% duty cycle. And let's move to the code. In the code, I have imported all the required libraries, and have configured required ports and stuff uh, as required. So in the code, I have created a 5 blink and a 10 blink function, which will help us to blink the onboard LED for 10 times and 5 times respectively. And also here I have used forward delay function that is for 2 seconds. That means LED will blink for 2 seconds 10 times, and also it will blink for 5 times, having 0.5 second delay each time. So when we program our board, the program will initialize press count with a 0, and I have also done onboard LED as input, and required output and input as required. So and in the program it will begin from while section. So if when we will not be pressing any button at first. So at that moment everything is set to 0, and press count is increased by 1 initially. So the program will uh, check the function. Press count is 1 obviously. So program will enter here, and there will be 10 blink function called, uh, which will blink the LED on board for 10 times. And after blinking 10 times, there will be 100% duty cycle. That means LED, which is green LED, will be illuminated with 100% capacity, and forward rotation will execute, and backward rotation is 0, and this will be continued until we press the button. So when we press the button, this will set the flag to 1, and the program will exit from this block of code, and it will again uh, go to the top, and press count will increase to 2 while resetting all other function, so that the motor will stop rotating, because rotation forward is 0 and rotation backward is 0, and press count will be 2. So the program will jump to this if section. So program press count is 2. That's why it will call the 5 blink function, which will make the onboard LED lead for 5 times. 5 times it will blink for 5 times, having 0.5 second delay between each blink. And the red LED will be illuminated, having 60% duty cycle. That means 60% capacity only it will lead. It will lead, yeah, the first 60% only. And rotation backward is 1. That's why it will the motor, our DC motor, will rotate anti-clockwise, and rotation forward is 0. So it will obviously uh, rotate anti-clockwise, while in this function when press count is 1, it will rotate clockwise, which is forward or clockwise. And in this function, then until we press the button, the function will keep running, and after pressing the button the flag will set to 1, and press count will reset to 0. That means from here the press count will be 1, and again this function will execute, making onboard LED 10 time blinking with a 0.2 second delay between each blink, and rotating the DC motor clockwise, having green LED lit. And now let's see the program in our live demonstration. Let's program our microcontroller and see what will be the output. Here I have a DC motor and a DC battery with 9 volt. Let's build the program first. The MPLAB will automatically program the code. Let's see. So after I press the button, the press count will be 1, and the LED on the board will blink for 10 times with 0.2 seconds, and after that a green LED on our proto board is illuminated, and the motor is rotating in clockwise or forward. As we can see, it's rotating forward, so in clockwise. So after pressing the button again, the LED board will blink for 5 times with 0.5 second delay, and a red LED on proto board will be lit, and the motor will rotate anti-clockwise. Here we can see that the motor is rotating anti-clockwise or backward indeed. So that is our lab